Hello. So I just wanted to do a quick summary on the stereo I've recently made, just because I'm quite proud of it. It's definitely the best thing I've made, at least since my actual solar system itself and my lithium-ion DIY, lithium ion phosphate DIY power bank, which has proven to be so useful. But this thing it's taken months to make, but works superbly, and something that I've always wanted to do, and just definitely worth a review in my opinion. So this all started quite some time ago, so it's October now, but it was about February or March after we got our Nissan Leaf. I bought some new speakers for the back of the car because the speakers that were in there were in such poor condition, and bought these speakers here that used in this stereo, these Alpine S65s. Unfortunately, these are 4 ohm speakers, and the speakers that need to go in the Leaf are 2 ohms, so I decided not to put them in. They probably would have gone in okay, but they would have had reduced volume compared to the fronts. And even after buying new speakers to put into the Leaf, some 2 ohms, even they are still relatively quiet compared to the front speakers. So I'm glad I didn't put these in at the end of the day. They work really well in this application. They're really highly rated speakers. I think they're 80 watts per channel RMS continuous, but they get very, very good reviews from the car audio websites. So I had these speakers left over, didn't know quite what to do with them. Thought I could use them for something. I mean, I've got leftover speakers from my old Panasonic microsystem I could have used anyway, but I thought these are such good speakers, they're probably worth putting to use somehow. And I couldn't imagine putting them in a car, especially not any of the cars that we own at the moment. Anyway, so I thought I'd use them here. And the other thing that had been going on at the time is playing with lithium cells as per usual. And I've been getting some lithium cells from Carla's parents with their, they have a few vacuum cleaners where the batteries were quote unquote failing. So I stripped some 18650 cells out of one of their vacuum cleaner batteries and thought, well, I can put the two together somehow, the speakers and the cells. So I ended up buying some more quote unquote failed vacuum cleaner batteries from Trade Me. Yes, it probably cost me about $60. I think I bought 3 more batteries, stripped the cells out of them. Most of the cells, well, pretty much all the cells are usable. They're down to about 2100 milliamp hour, down from the, I think most of them were 2300 or 2500 milliamp hour originally, but so they're all usable. It's just that they'd all gone out of balance and the control boards for the batteries couldn't cope with that, which is a pity really, because they had a lot more life left. Anyway, so I figured out I was going to do the battery pack this way, and this is a very expensive kit to connect cells together into a battery pack without soldering or welding. Unfortunately, you can see some of these caps have cracked already. So this kit costs about $100 off eBay. Had to be shipped from the UK. And so some of these are cracked and I'm getting them replaced, but I'm not convinced that'll solve the issue, but I'll come to that down the track. As far as I can tell, all the cells are making contact at the moment, so it is working. It's just probably not the best thing in the long term. Anyway, so I had a battery solution in my head for this unit, and then the question was what am I going to use as an amplifier, and started looking around, even buying new stereo units. Obviously I was going to go with a car stereo unit, looking at the dimensions of what the standards are for that. It was going to be the easiest thing to get all the features I wanted into a usable sort of stereo system, not just some sort of niche amplifier board, an actual thing that could take Bluetooth, CD, tuner all in one, and that was resistant to maybe electrical interference or any sort of power issues. So I was looking at this head unit. It's a Sony MEX N5300 BT, so Bluetooth capable. I actually looked at buying it brand new, but I actually found one that was only a year old, used in Hamilton, so I ended up driving to Hamilton in March or April, I think, in the Leaf. It's only about an hour away, and ended up picking this up for $100. So not cheap, but yeah, overall I think I've sunk about $750 into this system all up, including a $100 donation to my neighbour who did the cutting of all the MDF to my design. Lovely old chap who had all the gear to do it sufficiently, the gear and the knowledge. So yeah, so we've got the head unit, the battery pack. One of the challenges was the battery pack is a 5S4P system is how I've got it set up. So 4 cells in parallel, giving just over 8 amp hours, and being 5 cells in series, it gives a peak nominal voltage of 21 volts. So this was going to be too high a voltage to use with the stereo, which I think in its manual is rated from 11 to 15 volts. So had to use a DC-DC converter. So this is a DC-DC buck converter rated for, I think it's rated for 20 amps. This one, it's cheap off eBay, so whether it's going to last sufficiently long, I'm not sure. I'm not too worried as long as it doesn't destroy the stereo in the process if it blows up. But it seems to work fine. The stereo only seems to pull up to 2 or 3 amps at a time, so well within the circuit's theoretical capabilities. So this steps the voltage down from the 17 to 21 volts that I run the battery pack at to 13.4 volts for the stereo. So the critical part of this electronically that I had to solve was that obviously the DC-DC converter takes energy to run the whole time, and I didn't want it running all the time, sapping power from the battery pack when the stereo wasn't in use. So the solution to that was obviously to switch off the DC-DC converter. The problem with switching off the DC-DC converter is then it wipes the entire memory from the stereo. This was not ideal as the stereo uses, it's designed to be connected permanently to the car battery to maintain its memory. And it's just switched on and off by an ignition signal. So in this case, I needed some sort of backup battery supply to maintain the stereo's memory. So in this case, I've got 4 lithium iron phosphate cells, AA size, in series in this little case here. It powers the head unit, it's in parallel with the DC-DC converter output, and the DC-DC converter output voltage has to be really around 13.4 volts after the diodes, safety diodes I've got here, to charge the batteries through this resistor to an acceptable rate while the DC-DC converter is on. And so then once the DC-DC converter is switched off, this still maintains some voltage to the head unit to power the memory. So in terms of actual function, it functions very simply. So we've got tuner, CD player, Bluetooth, auxiliary input, and there's also a Sony app which I haven't played with yet, but at some stage I will. So we've got the 2 switches. One turns on and off the power to the DC-DC converter. So that's now on. And the other switch is the ignition wire signal for the stereo head unit. So this is what it needs to switch itself on. At the moment the head unit is switched off, so no source is being requested. Turn it on as per how you would in your car.
To see this movie.
And now
just quickly,
we have power.
we're used to super film now.
So it's a good quality head unit. As for the actual
seeing the natural world, we're used to the
stereo quality, the audio quality is pretty good when it's quite loud. Unfortunately, when it's at lower volumes, it does seem to dominate treble rather than bass. I could only do so much design with the speaker units to optimize for audio quality, given I wanted to make it easy for my neighbor to manufacture for me. Some of the other features I've added on, these cheap eBay sourced clips to add to mount monitors onto walls. Works very well in this application as long as you have this bumper here to stop the speaker twisting as it mounts. It does try and twist the mount off leading to some severely creaky, scary, creaky sounds. So that bumper really makes a difference. No noise at all when you pick it up. And then I also added in this voltmeter to check the voltage of the main battery, which is switched completely independently. Yeah, so that's a summary of that. Got the case for the head unit, so if I am transporting the stereo, because it can be hard to protect it from knocks, I take the faceplate off just to prevent damaging the faceplate. It's a metallic green paint that was really lovely. It's got a slightly blemished finish just from the rolling I did at the end, and then this handle, which probably doesn't really suit, but it definitely does the job. So yeah, that's pretty much it. I've got fusing on the negative and positive of the battery pack, so that's a 10 amp fuse there and a 5 amp fuse at the back on the positive side, and then there's a XT60 plug for socket for charging, which I have to do from a DC-DC boost buck converter from my solar, and two XT30 connectors for the speaker connections. So eventually, yes, we'll have a Perspex screen at the back and some sort of cable management system, but otherwise works very, very well. Very pleased with it. Over and out.